Welcome to Investigation 2.2. This is called the Drought Stopper. So, I have an invention that I hope that it will help stop droughts. It's called the Drought Stopper. I know. It's
such an innovative name.
I know, truly. Okay. Now, the Drought Stopper system is kind of like a black box. We can see what it does, but we can't really see how it's working on the inside. So, what you're going to need to do is during the investigation, I want you to figure out what is going on inside of the box. So the black box, if you will, it's a model of how something works. But your job is to figure out what's going on here to cause this to happen, okay? All right, so your challenge is to draw a model that explains how you can get an additional 500 to 600 milligrams of water out after putting only 100 milliliters.
What?
So I want to take in. Okay, so again, your challenge is to figure out what's going on inside the black box. So this is called a drought stopper because by producing or coming up with an invention that will take in the little bit of water that we have here on Earth that continually cycles through the water cycle, but all of a sudden, how can we produce more water than we're actually taking in? That's the big idea. Okay, so our focus question is, how might a drought stopper system work? That's our focus question. How might the drought stopper system work? Now, I'm going to make sure I'm doing this correct. So you're trying to come up with an idea of how this model works. And if it explodes, well, I tried. Okay.
Be quiet.
Okay. Okay. Right. Now, I am going to add one more. I have added 400 milliliters of water into this container, this black box. I'm going to tape it shut. So, if you notice, whatever I just did, I took water and put it into something. 400 milligrams of water and put it into something. Yes? Mm-hmm. Okay. Is anything coming out right now? No. How could that be?
Something's blocking it, maybe.
You think something's blocking it? Yeah. What do you think, Esme?
The water hasn't filled up so we could go to the tube.
But I put in 500 milliliters of water. I put in 500 milliliters of water. What do you think, Dexter?
You have to go through the tube in the top. Yeah.
Oh, okay.
Yeah, that's probably like a trigger plate.
Okay, so you think the funnel is going to trigger something?
Yeah, what else is there?
Okay.
Let's see if it connects to something.
Okay, so now, let me pour a little more. I'm going to put 300 milliliters of water. So, nothing's going on, right?
No.
Okay. I have 300 milliliters of water. I just poured water into a device, right? Okay. Okay. Is anything happening?
No. Not yet.
That's Mr. B's favorite word.
Anything?
Well, it's going down.
Okay.
Maybe there's something like water.
Oh, yeah.
Come on,
Maybe
you
there's
can do
something
it. Blocking it, but it's waterproof, so the water will go.
Okay. Is anything happening yet?
Nope.
Okay. So I have 200 milliliters of water left. So I just added 100 milliliters. So I started with 500. I added 100, right? Is anything happening yet?
Is it gravity?
No,
I think gravity. It's like you think electricity. I think it's gravity.
Maybe you have to
Okay. I just added. So I started with 500 milliliters of water. I have now added almost 300 milliliters of water more. Nothing is happening.
Oh, it's a trick. It's a trick.
Okay.
It's a miniature name.
Okay.
I think I know. Drought
Remember.
Drought Stopper.
Okay. Okay. I'm going to add another 200 milliliters of water. So we're at how much water is in this device?
Like 700 milliliters.
500 plus 300.
800.
Okay.
Wait, if you had two, that would be the same amount as the other. Do you have to put in the same amount of water as the other as the last time?
Oh, you think.
Balance.
Okay, so you think. So, Cooper, you think that I started with 500 milliliters of water and nothing's going to happen until I add 500 milliliters more of water?
Yeah, it's probably a weight system.
Okay. So, you and Kaden, you think it has something to do with weight?
Kind of like how a key, you know how keys, they all have to, all 5 of the pins have to line up. Maybe the 2 things have to line up in order for the water to go down.
Oh, interesting. Okay.
It's going to be something.
Oh!
Okay.
Can I touch it?
That was about 150 milliliters of water.
That's why you learn how to be a
so
plumber.
much. Oh, to see. There's a Pokemon.
Okay. Okay.
That's a lot of
What's going on?
That's a lot of water. There's something that's balancing it. So only
You could
a certain amount of water. Yeah, there's a balancing. Because you know how you put it in the box the first time, and instead of putting it through that, you put it through that one on the other side or whatever.
Interesting.
So it would be balanced. There must be like 2 separate containers that both look the same too. Yeah.
Oh, you think there are 2 separate containers?
Yeah.
Okay, Dexter, what about you?
One to this one and one to the other one. Something's stuck.
And then once that happens, double and immediately double, it lets out.
Yeah.
Because the pressure is the amount
Yeah.
of water.
Yeah.
It lets out like a black.
Yeah.
Okay, so you think it has something to do with pressure.
Yeah.
Okay.
I
Kaden?
think that maybe there's like maybe there was something in there and then maybe there's like a spring and then but when they both align it makes the spring open, which then lets the water come
Ooh,
through.
okay. All right. So, with your group, number 1, how does your model operate? What does it look like? How does it operate? What observations of the drought stopper support your model? What did you see here that supports your model? So, I'm going to have the hairy spiders, the seasick dolphins, yellow shoes, what dizzy birds, or where was it? Afraid of heights birds, dizzy birds, and then what? DB?
Scared cats.
No, you guys. You could be the overfed cats. Okay. Well, Cooper likes to eat In-N-Out burgers. So. Okay, I'm going to have you guys take a few minutes, and I want you to come up with a model. I want you to tell me what it looks like and what observations that you saw support your model.
I'm lost. What do we do?
Okay, so we had 1, 2, 3, 4, 5 groups share out their ideas of their models and what they thought. Now we're gonna now do the unveiling of the black box. Okay, so I have a funnel attached to a tube.
I knew it.
Okay.
Yes.
And then
We all knew that, Johnny.
I have another tube that's inside that is curled around. It's inside, but it doesn't touch the bottom. The tube does not touch the bottom. Okay. The tube does not touch the bottom.
Correct. I thought it was smart. Mom, why are you standing over there? I'm standing over there too.
I'm probably between best Hey,
Did it stop recording? You're still recording. Oh.
Okay. I knew it. Okay. All right. So let me explain to you. 3, 2, 1. All right. So this drought stopper uses a siphon to produce the interesting behavior you observed. A siphon is a tube filled with water with the outflow end lower than the inflow end. The inflow end is on the bottom of the container and the outflow end extends below the level of the bottom of the container. And I did hear a lot of that conversation going on. Gravity. Yep. Daniel kept throwing out it being lower using gravity. Now listen. Gravity makes the water flow from Gravity makes the water flow from the lower end of the tube, just as it would make water flow if a drain were on the bottom of a container. Water will flow through the entire tube until the container is empty. Stop. Okay, when the drought stopper was set up, there was air in the tube. The system was set up so that the water level in the container was below the highest point in the tube loop. With air in the tube, gravity could not force, gravity, Daniel, you kept saying that too, could not force the water over the top of the tube. When that last 100 milliliters was added, the water was added to the container.
Push it.
All right. Now, I know this is confusing, but we'll draw this out tomorrow. The last 100 milliliters of water was added to the container. The level of the water went above the loop. So here's that loop. The water went above the loop, and the force of gravity pushed the water into the entire tube so it flowed out the other end. Daniel, you were really almost spot on so much of that. Good job. All right, that'll do it. When we come back tomorrow, we'll actually draw this out. All right, have a good day.
I you too.